Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on thermodynamics from March 2022, paper 4, variant 2. I said this question is very important because in this lesson, we will discuss some key concepts about thermodynamics, and these key concepts are very important for your exam. For question number 2, it is given to us a fixed mass of an ideal gas has a volume V and a pressure P. The gas undergoes a cycle of changes from X to Y, Y to Z, and finally Z to X, as shown in figure 2.1, as shown on this PV diagram. Question is asking us, for part A, we need to state the change in internal energy delta U for one complete cycle X, Y, Z, X. Means for the gas, if this is the complete cycle from X to Y, then from Y to Z, and finally from Z to X. If this is a complete cycle for a gas, we need to state what is the change in internal energy. Let's try to understand some key concepts about internal energy before we answer this question. So the first key concept you need to understand is delta U is equal to 0 if the initial and final state are the same. If initial and final state are the same. So simply we can say if initial and final states are the same. Initial and final states are the same for any ideal gas. In that case, delta U is equal to 0. Or simply we can say for any complete cycle, means if gas undergoes a cycle of changes. So we can say for any complete cycle, delta U is equal to 0. So very important point. Actually, this point you need to answer this question. And the second thing we need to understand is that we can also say delta U is independent of path. It doesn't matter if gas started from here, for example, from X, it goes this way, then go this way, then go this way, and finally come to this one. Still, delta U is equal to 0 if initial and final states are the same. So in this case, you can see this gas undergoes a cycle of changes. That's the reason delta U has to be equal to 0. And this is B mark. If you have written this one, you will get this 1 mark. For part B, question is asking us to calculate amount N of gas. Means question is simply asking us to calculate value of N. Means the number of moles. And we are talking about ideal gas in this case. For any ideal gas, PV is equal to nRT for any value of P, for any value of V, and for any value of T. So simply in this case, we need to calculate N, we need to calculate number of moles. So simply we can rearrange N is equal to PV over RT. For this ideal gas, value of P is given to us. So this is value of P. So simply we can plug in values now. We can say P is equal to 1.5 times 10 to 5, and we need to multiply this one with V, and the value of V is given to us, and this is equal to 4.2 times 10 to negative 3, and we need to divide by gas constant, and value of gas constant is 8.31 joules per mole per Kelvin. So we can plug in this value here, and finally temperature has to be in Kelvin. Temperature is already given in kelvins, so simply we can plug in value of temperature. So if we calculate this one, our final answer will be 0.14 moles up to 2 SF. So this is our final answer up to 2 SF. We have to use 2 SF in this case because the least number of SF we have is 2, and here also we have 2. So our answer has to be up to 2 SF. And this is our final answer. This question has only 2 marks. If you have used this formula, you will get 1 mark. And if you have got the right answer, you will also get a second mark. Means you will get 2 marks in total. So this is how we can answer this type of problems. For part C, we need to complete table 2.1. Means we have to enter the missing values of P and missing values of V in this table. So these missing values we have to enter. In order to answer this question, we need to understand two things. First thing, we need to understand how to use PV is equal to nRT, this ideal gas equation. And the second one, we need to understand how to read PV diagram. So this is the first thing you need to understand. The second one, you need to understand how to read PV diagram. If we look at X and Y, so the value of P at this point and value of P at this point is the same. So simply we can say the value of P for state X is the same as value of P for state Y. And that value is given here. That is equal to 1.5. So simply we can say this is equal to 1.5 times 10 to 5 Pascal. So here we can enter for Y. This is also 1.5. So this is how you can find the value of P at Y. Now let's try to find out value of V at Y at state Y. So simply we can say this is Vy and we need to find out value of V at Y. For that purpose we have to use this ideal gas equation. We can say in this case V is equal to nRT divided by P. And we have already calculated that was equal to 0.14 moles and R is gas constant, so we can say this is 8.31 joules per mole per Kelvin and temperature is in Kelvin. T has to be in Kelvin. It is already given, it is in Kelvin, so we can write down value of T. Now we need to divide by value of P, and the P at Y we have, that is 1.5 times 10 to 5. Now if we solve this one, our final answer will be 1.8 times 10 to negative 3 cubic meters, and that is the answer for V. So simply we will write down V is equal to 1.8 cubic meters. 1.8 times 10 to negative 3 cubic meters, because 10 to negative 3 is written here. So you no need to write down here. Now we need to find out value of V at Z. If you look at this one, from Y to Z, there is no change in volume. So volume stays constant, but P is increasing. So simply we can say Vy is equal to Vz. We can read this one simply from diagram. So value of V at Z is also equal to 1.8 times 10 to negative 3, and that is the answer. This question has 2 marks. If you have got right value of the P, you will get 1 mark, and this is the mark. And if you have got these 2 values right, you will get the second P mark. So this is second P mark. For D, it is given to us the first law of thermodynamics for a system may be represented by the equation delta U is equal to Q plus W. We need to state with reference to the system what is meant by these symbols. First one is delta U. Delta U simply is the change in internal energy of the system. So we can say this is change in internal energy of the system. So this is how you can write this, change in internal energy of the system. So this is one thing you can write down. Even you can say increase in internal energy of the system. It can be positive or negative. Q, next one is the Q. Q is heat supplied to the system. Better way to say this one is thermal energy supplied to the system. So this is how you can write down thermal energy supplied to the system. So you have to write down system here. Next one is W. W is the work done on the system. So W is work done on the system. Often we say work done on the gas. So gas is our system. Work done on the system. So this is what you need to write down for part 1. If you have written this for delta U, you will get 1 mark, and this is B 1 mark. And for Q, you will also get 1 B mark. And for W, this is also another B mark. If you have written these 3, you will get 3 B marks. For the second part, question is asking us to explain how the first law of thermodynamics applies to the change Z to X. Means from this state to this state. Z to X. Z to X. But if you look at Z and if you look at X, simply we can see that the volume is increasing from Z to X. So the gas is expanding. So this is expansion. We can also find out from this table, if you go from Z to X, so this is the value of P actually, but if you look at value of V, so you can see from Z to X, V is increasing. So we can write down V is increasing. decreasing. So this is expansion process. If it is expansion, it means work is done by the system, or we can say work is done by gas, and work done by gas is taken as negative. So this is one thing we can get from this PV diagram. Now let's look at temperature now. If we go from Z to X, you can see the temperature is decreasing. So if temperature decrease, it means delta U is negative, means the change in internal energy, this is negative. So this is negative because delta U, this is equal to 3 by 2 K times delta T. If the change in delta T is negative, it means delta U is negative. Now if we write down the first law of thermodynamics, we can say Q plus W, this is equal to delta U. As the change in delta U, this change is negative, and W, this is also negative. But for the Q, it can be positive, it can be negative. It depends on the exact value of Q, means how much Q has been added. So it can be positive, means heat can be supplied to the system, or heat can be released from the system. It depends on the exact values of W and exact value of delta U. But we don't have the exact values of delta U, and also we don't have exact value of W. So we cannot say something about Q. So simply we can mention these 2 points. So we can say as volume increases, work is done by gas. As temperature decreases, it means internal energy decreases because the change in internal energy is negative. So you have to write on these 2 points. You will get 2 marks. But don't try to explain this one with the help of thermal energy, because that is not possible, because we don't have the exact values of W and we don't have the exact value of delta U. This is how you can write down your final answer. If you have mentioned these 2 points, you will get 2 marks. As volume increases, work is done by gas. So this will be 1 mark. You will get 1 B mark for this one. And the second B mark is if you have written temperature decreases, so internal energy decreases, you will get second B mark.